Hey everyone, welcome to this explainer. I am so incredibly thrilled to have you here today, mostly because we're looking at a massive, undeniably huge shift in the world right now. I'm talking about the way artificial intelligence is literally rewiring the workforce from the ground up. Now, if you've been wondering how you're supposed to navigate this transition, you are in exactly the right place. We aren't just going to sit here and talk about abstract, high-level concepts today. Instead, we're laying out a really actionable, step-by-step roadmap to help you genuinely master AI and completely thrive in this new landscape. To do that, we've got a pretty tight agenda today. We're going to cover the future of jobs, defining artificial intelligence, your AI learning roadmap, advanced models and deployment, and finally, we'll wrap up with prompting versus fine-tuning. Okay, let's dive right into this. Section 1, the future of jobs, how AI reshapes work. According to some deeply insightful recent microeconomic modeling from Boston Consulting Group, over the next 2 to 3 years, 50 to 55% of jobs in the U.S. will be reshaped by AI. Let that sink in for a second. That is a staggering figure, over half. For the vast majority of us, the expectations around how we work and what we produce are about to radically change. BCG actually categorizes this impact into a few distinct labor segments. First up, you have amplified roles, think software engineers. Here, AI augments human capability and demand actually expands, so humans remain central and the work just grows. Then you've got rebalanced roles, like content marketing. This is where AI handles the routine, tedious tasks so the worker can focus on complex, big-picture strategy instead of just banging out a first draft. Next are divergent roles, like insurance sales. In these, entry-level tasks get automated, but the advanced, high-level advisory roles totally persist. And finally, substituted roles, like call center reps. These face actual job reductions because, well, AI can reliably handle those repeatable, bounded inquiries from start to finish. But wait, before you panic, I really want you to focus on this quote from the report. Task automation doesn't equal job loss. While BCG does note that 10 to 15% of U.S. jobs could be eliminated over the next 5 years, the real story here is adaptation. If your job falls into that 55% being reshaped, your daily work is simply going to evolve. Upskilling is absolutely your key to staying on the winning side of this massive shift. Which brings us to Section 2, defining artificial intelligence, building the foundation. To survive this economic shift, we first need to define what it is we're actually dealing with. And there is a vital distinction you need to make here. Weak AI, or artificial narrow intelligence, is what we use every single day. It's trained to perform highly specific tasks, like translating a text message, recommending a song on Spotify, or steering a car. Strong AI, on the other hand, is artificial general intelligence. This is that sci-fi concept of sentient machines that equal or exceed human intelligence across the board. The important takeaway? We are currently living strictly in the era of weak AI. In fact, researchers break AI down even further into 4 theoretical types. First, we have reactive machines, which only react to the present moment, like a chess-playing computer. Then there are limited memory machines, which understand a little bit of the past. This is the tech that powers today's self-driving cars, so they can interpret their surroundings on the fly. The next 2, theory of mind, where machines actually understand other entities, and self-aware machines, the stuff of movies. Those remain entirely theoretical at this point. So the crucial point here is understanding generative AI, which is the exact technology powering tools like ChatGPT. I know it feels like you're talking to a self-aware being sometimes, but generative models are simply responding to your prompts by producing original content through incredibly complex, deep statistical analysis. It's just math and pattern recognition, guys, not actual sentience. Moving right along to Section 3, your AI learning roadmap, step by step. So how do you actually learn to build this stuff? Well, we've curated a curriculum based on guides from Coursera and software engineer Mosh Hamadani. And this brilliantly illustrates that mastering AI is a structured, multi-phase journey. You can't just learn this over a long weekend. Going from absolutely zero to a competent machine learning engineer takes a dedicated 12 to 20 months of focused, serious study. Here's how that timeline actually breaks down. You're going to spend your first month or 2 purely on Python programming and Git for version control. After that, you spend 2 to 3 months solely on math and statistics. Only after that solid foundation do you spend 3 to 4 months on machine learning fundamentals, before finally tackling advanced deep learning. Basically, foundational coding and math strictly precede the complex neural networks. Now, you might be wondering, why on earth do I need math? Think of math as the vegetables in your AI diet. You really can't skip them if you want a healthy, functioning model. Without it, you just won't be able to troubleshoot complex problems. Linear algebra gives you the matrix operations you need for neural network computations. Calculus powers optimization algorithms, like gradient descent, which actually help the model learn. And probability and statistics, they allow you to evaluate how well your model is actually performing and deal with all that inevitable data uncertainty. Once you hit those machine learning fundamentals, you'll encounter three core paradigms. First, supervised learning, which trains on labeled data to make predictions. Think of a spam filter in your email inbox. Second, unsupervised learning, which looks at unlabeled data to find hidden patterns. A good example is segmenting customers for a marketing campaign. And third, reinforcement learning. This relies on trial and error with a reward system, which is exactly how AI agents learn to play video games or navigate robotics. To truly learn all of this, you absolutely have to get your hands dirty with real projects. You start simple and iterate. So step 1 might be building a basic text classifier for spam. In step 2, you level up to things like image recognition or a simple chatbot. And by step 3, you're taking those models and deploying them onto cloud platforms like AWS or Google Cloud to serve real users at a massive scale. Which brings us to Section 4, Advanced Models and Deployment, Reaching the Expert Level. Now, what's really interesting here is what happens when we shift our focus from playing with theoretical models in a sandbox to real-world production. You really have to choose your tools based on your end goal. These are the 3 leading deep learning frameworks. If you're a beginner looking to do rapid prototyping, Keras is incredibly user-friendly. If you're doing advanced research and you need tons of flexibility, PyTorch is definitely your go-to. But if you need to deploy a massive application at scale in a live production environment, TensorFlow is the absolute industry standard. Also, when you're building these deep neural networks, the architecture totally matters. Convolutional neural networks, or CNNs, are designed for static, grid-like data. They use filters to detect edges and textures, which makes them absolutely perfect for image processing. Recurrent neural networks, or RNNs, on the other hand, are completely different. They maintain an internal memory state, making them ideal for interpreting sequential data over time, like a continuous stream of spoken language or text. Look, getting a model to work on your laptop is one thing, but MLOps, machine learning operations, is how you get it out into the world. The standard pipeline involves containerizing your model with Docker, so it runs consistently anywhere. Then you create API endpoints so other applications can actually talk to it. You've also got to implement auto-scaling to handle unpredictable user traffic. And finally, you have to constantly monitor for data drift, just to ensure your model's accuracy doesn't degrade over time out there in the wild. Okay, let's move to our final section and see how this all builds together. Section 5, Prompting versus Fine-Tuning, Customizing Enterprise AI. When businesses use large language models, they face a really critical decision on how to customize that AI. According to data integration platform Nexla, these 2 main approaches, prompt engineering and fine-tuning, are vastly different. Prompt engineering is super lightweight. You're simply tweaking the input text to guide the model's output without changing any of its internal parameters. It's incredibly fast and highly flexible. Fine-tuning, however, involves actually retraining the model on a specialized dataset. It adjusts the internal weights of the model itself. This is highly resource-intensive, but it yields amazingly high accuracy for very specific tasks. Now, if you are taking the prompt engineering route, there are best practices you absolutely must follow. You need clear task alignment and continuous iterative refinement based on what the model spits back at you. Most importantly, you need to use few-shot examples, which basically means you actually provide the model with a few examples of the exact output you want, right inside the prompt. I promise you, this drastically improves the final result. Utilizing templates also really helps to standardize this whole process. But here is the ultimate enterprise reality. While prompting is a fantastic, highly flexible tool, it does limit models to their original knowledge base. For mission-critical enterprise environments, fine-tuning is absolutely essential. It's really the only way to ensure strict data governance, deeply customize the model to niche company data, and minimize the risk of costly errors or hallucinations in applications where failure simply isn't an option. We have covered a ton of ground today, right? From the macro shifts in the job market all the way down to the super technical nuances of fine-tuning neural networks. Knowing that 55% of jobs are actively reshaping over the next few years, standing still is a risk you honestly just can't take. So, looking at the 12 to 20-month roadmap we laid out today, what is the very first step you're going to take to start upskilling? Thanks so much for joining me on this explainer, and I'll see you next time.